Hello everyone, I am Karthik from ITI section. Today my topic is about irregular indeterminate repeated phases in temporal relational databases. Let us know what is irregular indeterminate repeated phases in a temporal relational database and what is relational databases. In further slides briefly, let us see the abstract. Time is pervasive of reality and many relational database approaches have been developed to cope with it. In practical applications, facts can repeat several times and only the several overall period of the time containing all the repetitions may be known. Consider example on January, John attended 5 meetings for the bioinformatics project. While some temporal relational databases have phased facts repeated at a periodic time, or signal facts occurred at a temporal indeterminate time, the conjunction of a non-periodic repetition and temporal indeterminacy has not been faced yet. Coping with his problem requires an in-depth extension of current techniques in this paper. We have introduced a new data model and a new definitions of relational algebraic operators copying with the above issues. We have studied the properties of the new model and the algebra with emphasis on the reducibility property and how it can be integrated with others model in the literature. This is the abstract of our topic. Let us see the more information in further slides. Introduction. Coming to the introduction, time is a pervasive of our way of dealing with. As a consequence, time is often modeled in databases. The scientific community agrees that time has a special status with respect to the other data, so that its treatment within a relational database context requires dedicated techniques. A plethora of dedicated approaches have been developed in the area of temporal relational database (TDB) in the following, and the different approaches have been proposed for supporting efficient access to temporal data and improving the effectiveness of information retrieval. Most TDB approaches focus on the individual occurrence of facts, whose time of occurrence is exactly known. However, in the real-world applications, it is often the case that the same fact event is repeated several times. Thus, Helen and Clifford distinguish among strongly periodic events occurring at equally distant intervals of time. Example, Monday's weeks. Nearly periodic events occurring at a regular interval of times but not necessarily at equally distant intervals. A person going to cinema once. So let us see main problems and solutions for this. We aim at identifying a data model and relational algebraic operators to cope with the irregular indeterminate repetitions in TDBs. The data model must be closed with respect to the algebraic operators to query it, so that the results of the application of such operators must still be expressible in our data model. Such a goal leads to important implications about our data model. We proceed incrementally. First, we focus on the exact cardinality and the convex frame time, and then we generalize. Two different problems have to be faced to cope with cases like repetitions of facts and the temporal indeterminacy. As regard repetitions, we could allow for duplicates. Several tuples representing occurrence of a value equivalent facts holding at the same frame time could be inserted in the same relation. However, the adoption of duplicates has several disadvantages. Example, as regards space and cannot be generalized to the space in which the exact number of repetitions is unknown. Thus, purpose a compact solution where numeric attributes are used to represent the number of repetitions of a fact in a frame time. Data model. Let us see what is data model. Tuples are associated with a valid time. For the sake of the brevity, transaction time is not considered in this paper. The timeline is partitioned into granules of a chosen basic granularity as a BCDM, which is the semantic model underlying many TDB approaches, including the consensus. The time domain is totally ordered and is isomorphic to the subsets of the domain of the natural numbers. The domain of valid times dvt is given as a set dvt equal to t1 to and so on decay of the granules. The number of repetitions of a fact is encoded by two cardinality attributes n and m defined on the domains of the natural numbers of the positive natural number respectively, with the constraint that the minimal cardinality is less or equal that the maximum cardinality. The schema of the IR irregular repeated temporal relation R equal to A1 and so on AN consists of encoding some factor of a minimal cardinality attribute n of a maximal cardinality attribute m and of an attribute ft representing a frame time as a temporal element, a set of non-overlapping time intervals. Temporal relational algebra. Code defined as a complete any query language that is as expressive as it is set of five relational algebraic operators: relational union, relational difference, selection, projection, and Cartesian product. Here it is an image describing the relational database. We purpose a Here we purpose a temporal extension of a code's operators to query the data module in section 3. Several temporal extensions to code operators have been provided in the TDB literature. In the most cases, such extensions behave like a standard non-temporal operators on the non-temporal attributes and involve the application of a set operators at the temporal attributes. For instance, in a TSQL2, consequences approach Cartesian product involves a pairwise concatenation of the values of non-temporal attributes and a pairwise intersection of their temporal values. Difference RS operators in the standard way on the non-temporal attributes and make the difference of a valid times by subtracting from each tuple f belongs to R the valid times of all tuples f dash belongs to s value equivalent to it, and relational union and non-temporal selection and projection operate in the standard way on the non-temporal part and do not operate on the temporal part. Relational algebra for irregular repetitions. We ground our approach on such a consequences background, extending the algebraic operators to cope with the new attributes. In the definition, we use the superscript IR irregular repeated or for our operators, while union intersection denote standard set operators. For the sake of brevity, we permanently define the set VE int of f comma s of the all tuples in the relation s that are value equivalent to an tuple f, that is that are equal to the f as regards the value of the non-temporal attributes whose frame time intersects with the f dash s frame time. In the following, x stands for all the x such that. Here there is another image difference between red intervals and blue intervals. The figure shows an example. Discussion and conclusion. Coming to the conclusion, despite the importance of the phenomenon, our approach is the first TDB approach, copying with the regular indeterminate repetitions of facts in the frame time. We have introduced a new data model and a new relational algebraic operators, and we have studied their reducibility properties. In section we have also started to analyze the integration of our approach with the ITE1 and with the current approaches copying with the periodic events. In our future work, we aim at the further exploring such an promising research direction by devising a temporal relation approach, data model, and algebra, copying with the nearly periodic events. Thank you. This is about our topic. Thank you.